Hi, everyone. Welcome, Azure Cosmos DB Live TV, episode 21. I've got with me a couple of special guests this week, Abinav Rameesh from the Cosmos DB team and Alicia Moniz from Confluent. How are you guys?
Good. How are you?
I'm great. Enjoying it, enjoying the sunshine, enjoying my summer. You guys, or Alicia, Confluent just announced the GA for the Cosmos DB connector. Is that correct?
Yeah, it's been amazing how quickly the Microsoft development team and the Confluent development team have been working. They've been working almost hand in hand with developing this connector. And I remember we were talking about the self-managed connector going GA just a couple of months ago. So it's amazing to have the fully managed connector available on Confluent Cloud now.
Yeah, that's great. I know there's been a lot of excitement about it. I know a lot of people in Microsoft are super excited about it. I won't name names, but we all know who they are.
We all are.
But so you guys are going to talk to us today about this Confluent connector, this Kafka connector, and show our audience, I guess, what this thing is all about and what it can do. I think, Ramesh, did you want to do some slides, or you guys want to talk about this at first, or how you want to?
Yeah, I can do both. So essentially, just for a very quick overview, this was sort of like a journey that started, at least in the ideation phase. We were thinking about this in April of last year, where we were like, hey, there's a lot of traction. This Kafka ecosystem is something that we really need to tap into. Sort of became an extension of our Java ecosystem as well, just because of Kafka's own platform being built on Java and things like that for the most part. And then usage and demand in general just picked up pretty significantly. And then towards the end of the year, we were like, okay, we really need to get this going. And so that's sort of where the whole thing started. And multiple teams within Microsoft, and of course the Confluent team that we've been partnering with, it's been a wonderful partnership. So yeah,
So
that's
there's a
sort
lot
of
of demand, I guess, then from customers who wanted to connect data in and out of Cosmos DB, and we're using Kafka already. Is that right?
Yeah, and what we started to notice was they were creating their own pipelines essentially to move the data on either side. Some scenarios it was more on the sink, some scenarios it was more on the source. And we just felt like for the most part, that's something that we could help them with. It was almost like they were building their own version of a connector that we could easily create given the similarities between Cosmos and Kafka in general. Mm-hmm. So that's sort of where it came from. And it's something that we just wanted to add on to our growing list of connectors using our SDK anyways. So.
Sure. I mean, it makes a whole lot of sense. I mean, the easier you can make it to get data into Cosmos or into any database.
Yeah.
Right. And nobody builds a database in a vacuum. So you've got to be able to connect it to other systems. And certainly that's what customers have been doing or we're trying to do. So that's great that we've really reduced a lot of friction for a lot of customers building this thing. So I think that's why we're seeing probably the amount of excitement that we have over this thing. So, yeah. So, are you going to share your screen there, Abinav? I lost your screen there.
Yes,
I think you were going to show us some lovely slides.
Yes. Let me know if this comes through.
Yeah, we got it. There we go.
Okay, perfect. Okay, cool. Well, for folks who don't know me, my name is Abinav. I'm a PM on the Cosmos DB product team. Work on a bunch of different spaces. On the one side, there's customer success. We work very closely hand in hand with some of our larger customers and really help build out solutions, funnel that back into feature growth and things like that. Another piece is on the Kafka ecosystem, and that's where the Kafka connectors really come into play. So really excited about it. We also have Alicia from Confluent, our partners in crime that have helped us walk through this entire process. So at some point, I'll hand it over to Alicia as well to go through a demo and really show the beauty of the connectors, really. So in terms of the direction in which we wanted to go, we're going to start off with just talking about what Kafka Connect really is. What do we get out of these connectors? What's the value add and how does it help? A little bit about the architecture in itself and the ease with which it can be used, and so what that really means. I'll get into a little bit more detail on what that integration with Cosmos looks like. So where does this relationship work out so well between Cosmos and Kafka? What is it that we wanted to help solve from an end user perspective, and some of that. I'll do a little bit of a deeper dive into the underlying architecture. So we'll actually start off talking about why they're similar in many aspects. And then when we get into this piece, it'll make even more sense when we just do a view of what it looks like under the covers. I'll hand it off to Alicia for a demo on the sync connector side of things, which is the fully managed Cosmos DB connector that we just went GA with. And then finally, just a quick overview on what this means. So we've got this integration with Cosmos. We've got this integration with Kafka. There's a way to move data in and out on either side. But what does that mean if we wanted to take it forward? Sort of like an extension of what we have when we cover section 2 right there. Right?
Great.
Cool. So what are we really talking about when we mean connector for Kafka? So essentially, there's a rich ecosystem of connectors which serve as a zero-code data import-export solution. And it really helps you move data in and out of Kafka. So a source connector, the way we would think about it, is the source and the sink are with respect to the data store. So when we think about Cosmos DB, a source connector is essentially saying, I'm going to pull from the source, which is Cosmos, and then I'm going to move it into Kafka. And the sink is essentially doing the exact opposite, which is I'm going to pull from Kafka and write it into the sink, which is Cosmos DB, right? And what you get through Confluent is a massive, essentially a plethora of connectors that are officially supported. And so now you have a way of tying in these two systems without writing any code. So you're deploying something, you're saying this is the connector that I want to use, this is the direction in which I want to go, and it's right there. And there's a little bit more that you can do with this as well, and I'll get into that in a second. And as far as how we want to run it, so you have the ability to run it as a fully managed connector. You have the ability to run it as a self-managed connector as well. So if you want to look for something that is the least hands-on approach, you would go through Confluent, spin up a Kafka Connect cluster. I'll get into what that means in a bit. And then specify the connector that you want, and then that integration is set up. But if you've been doing this for a while and you have a bunch of in-house expertise for this, you can also provision your own Kafka clusters, then provision your own Kafka Connect clusters, pull down the connector yourself, have that running, and then configure it to pull from the data source or write to the data source that you want. And then you can run it in that way as well.
Is there kind of guidance on how big of VM or cluster that you should provision? Kind of like rule of thumb, like you need this size or this number to push this much data?
Yeah, it's a good question. So it's very similar to what we see with how customers look at Cosmos DB on the change feed side of things. So if you're going to be doing very, very little heavy lifting in terms of what you're doing in the handler, and then literally just pulling from the source, writing to somewhere else or whatever it is that you want to do, something like a 4-core VM typically would do per instance. But the more heavy lifting you're doing within the handler, once the changes have been pulled in, if you're doing any complex transformations and things like that, you'd obviously want to have bigger, beefier machines. So typically what we would say is if it's just a massive scale in terms of number of data points that we're pulling and writing, you could probably have more workers, but each worker is smaller. But if there's more involved per worker, then maybe even doing something like an 8-core worker and then just scaling that out, very similar to how we do with change feed in Cosmos, is the recommended approach here.
I see. Do they? So you mentioned change feed. Do they have like is there like an estimator like we've got in change feed that can kind of you can use to say how far behind I'm falling?
Yeah. So there's a couple of ways in which you can do this in Kafka actually. So it's not quite well, actually there's more recent versions that do give you a better estimate, but historically it used to be, here's the offset on this partition in Kafka, for instance, that we've pulled changes up to, and here's the latest offset. So that kind of gives you an idea of how far you are. But I think more recently there are some better ways of associating an offset with a timestamp, so you can actually see in terms of an estimate, even in terms of time, how far back you are.
I see. Yeah, cool.
So, okay. And
I'm
yeah,
going to continue asking you dumb questions, by the way, all throughout the show.
no, actually, these aren't dumb at all. This is very
It's
common.
what I do.
This is, and yeah, in terms of running this, you can do this as a standalone. You can do this as distributed. The recommendation in the Kafka world is to, even if you don't have very high scaling requirements immediately, to always start off in a distributed manner, but still just have one worker. That gives you the option to add more workers easily, as opposed to switching from standalone to distributed and then going through all that madness. So in terms of what's happening under the covers with a Kafka Connect architecture, what we're actually doing, sorry guys, give me a second.
Oh, no worries. My 4-year-old watches it on my show all the time, so it's okay.
So this is the architecture under the covers that we have, right? So and this is within Kafka Connect. So we haven't even gotten to the Cosmos specific piece yet. So we're talking about a source connector. You've got Cosmos DB as a source. That central piece is composed of 3 components, and that's really what Kafka Connect is made up of. So you've got a connector, and then this is the jar that is going to be pulling from your source, in this case Cosmos, right? And then this is what's under the covers using our Java v4 SDK. It's running the change feed processor under the cover. So this is all Cosmos specific. Any other data store is going to have its own connector that you could configure. What you can do after that is what we call our transformations. So this isn't anything complex. It's literally a single message transformation that you're applying a transformation on for each message that we've pulled from Cosmos. So literally each JSON document, you may want to do something with it. So you may want to mask a field, you may want to encrypt a field, you may want to remove a field, add a new field. Based on 2 or 3 fields, you may want to create a new field. It's an aggregate, but it's nothing distributed. It's literally just for that single message that came in from the connector, right? Simple example of this actually is this may not work so much on the source side, but let's say you're pulling from Kafka and writing to Cosmos. That Kafka record may not have an ID field, or it may not have the partition key field. So you may want to generate both of those in the transform layer before pushing it on either side. And then the final piece to all of that is, so we've gotten the individual document that came in, we've applied the transformation that we care about, and then we want to do some sort of a data format conversion. So we may want to convert this from JSON into Avro and move it into Kafka. This just makes it more uniform so that any downstream application can just pull in. It always knows it's getting the data in Avro, as opposed to saying, oh, is it in JSON? Should I do some conversion myself? Right? And so this gives you the flexibility to do that as well. And the key thing to note here is that this is all 0 code. So you're controlling all of this through just configurations. You're configuring the connector that you want, you're configuring the transformations that you want to do, and you're configuring the conversion that you want to do as well. The only thing where it can get a little messy is if you're doing chained transformation. So you're literally doing transformation 1, then transformation 2 on top of that, transformation 3 on top of that. You're specifying all of these as transformation configs. And that can get a little messy if you're doing something super involved. But this is the power that you get with Kafka Connect.
So could I write these transforms in code? You're saying I don't need to do code. I can do, I'm guessing, what, a handful of relatively simple things.
Yeah.
With maybe casting things into different types.
Yeah.
Can I do things like flatten out hierarchies and
what you could do? Yeah. So what you could do with something that specific is you could technically have your own class that's a transformation class, and you can call it, let's say, flattening transformation, for instance, right? And let's just say there's more involved. You'd have to inject that into the Kafka Connect cluster, and then you can just call on that and say, this is the kind of transformation that I want to do. So there is, if you wanted to write code, you can certainly do that as well.
You could, and then I could write that in pretty much anything I want, basically. Just implement their interface, or implement the interfaces, I guess, and write the code.
Yep, exactly, exactly. Okay, so now in terms of the similarities that we actually have when we think about these 2 systems. So obviously one is a database, one is really more of a, you can think of it as a messaging system if you want. It certainly does more than that, but there's some fundamental similarities that actually make this fairly smooth. So the most obvious one is the sharding, right? They both have physical partitions. They both have replica sets for each of those physical partitions. The one difference between the two is when you create a Kafka topic, you're usually specifying the number of partitions that you want up front. With Cosmos DB, you're not doing that. We're managing all of that for you. What you're telling us is, what is my throughput requirement? How many reads, writes, queries do I want to do? Over time, my data is going to grow. So it needs to be distributed, and then we manage that completely on our side. On the Kafka side, you have a little more control. So you can specify how many shards you want. You can increase, decrease those shards. You have some flexibility there. And then everything beyond that is taken care of by the ecosystem. In terms of visibility, even though you're not controlling the shards in Cosmos, you do still have some visibility in terms of metrics. If you went into Azure Monitor, you can take a look at whether your data is well distributed, requests are well distributed. You can do more in log analytics as well through that integration, get more out of a deeper view if you wanted to. But it's something that's fundamentally very similar between them. Scaling is another huge similarity between them. So again, because they're both distributed horizontally, scaling is also something that is fairly seamless. On the Cosmos DB side, again, when you think about scaling, you're not thinking about literally what you're doing with the underlying partitions and things like that. We manage that for you entirely. There's budgets per partitions. You can do auto scaling. We scale out under the covers anyways for storage reasons. So all of that is managed. Kafka, again, you have a little more tunability from that standpoint. You can increase the number of partitions. You can specify things like log file sizes and things like that when you start nearing your limits, and when based on those limits you start increasing things. Typically, in the Kafka world, what you would see is usually it's the consumers that end up driving the scaling requirements. What I mean by that is the producers are just pushing data to topics, but ultimately you'll see multiple consumer groups coming in and then pulling this data from Kafka. And the more consumer groups you have for a given cluster, that's typically what dictates how far you want to scale. The next piece to this is probably what makes the foundation for our entire connector framework. CDC is probably the biggest similarity between the two of them. So when we think about Cosmos DB, and we'll get into this in the next couple of slides in terms of what's happening under the covers. But really what's happening is we have something called a change feed processor. And that's supposed to know all about the topology of your instance, knows all about the physical partitions. It knows about scaling out operations that have happened, new partitions that have come in over time, which physical shard owns which subset of your data from a logical standpoint. And then we're also doing things like checkpointing. So if you've got 10 different VMs running CDC, we've got things like lease management and making sure that no two pieces of your compute framework are pulling up the same changes from the same partition. So all of that is handled for you. There's obviously checkpointing as well. So every couple of minutes, there's progress that's being logged into a central container in Cosmos, and that's how all of these VMs and the distributed compute communicate with one another. Kafka is exactly the same. So you've got consumer groups. So this could really just mean 10 VMs that fall into the same group. They all have a group ID. That group ID is essentially what tells Kafka that all these guys are part of the same group. And so make sure that they're not listening to the same set of changes in a distributed manner. So that lease management is handled by Kafka for you. Kafka does offsets. The VM goes down, the next consumer comes in, picks up from the previous offset. Cosmos is doing exactly the same thing. This is basically the bare bones of our connectors on both sides. Biggest similarity.
What are the delivery guarantees for Kafka?
So Kafka does an at least once delivery guarantee.
Okay, so we're a little different. We're exactly once, I believe, for change feed, right?
So even in that scenario, what we're saying, the reason it's at least once even on the Kafka side is technically your handler. So when you're saying, I just want to use the consumer, so the consumer goes and brings me the changes. If the handler throws an exception and it never ends up pushing that offset, it could actually go back to the same thing and come back.
Hmm.
So essentially what we're saying is you could end up getting the same thing again. Technically in Cosmos that can happen as well, because if in the handler we throw an exception again and again and again because you've just written something that hits some edge case and it never moves forward, you could run into that problem in Cosmos as well. So from that standpoint, it's essentially exactly the same.
Okay.
And tunability, this is a little different. You're tuning different things in Cosmos. In Cosmos, you're tuning things like indexing policies, and even if we look at the client specifically from a CDC standpoint, how frequently do I want to poll Cosmos for the next set of changes? Queries, things like max item counts, bucket item counts, and all of that. You have some flexibility there. With Kafka, you're tuning things at a little lower level. You can actually specify the number of partitions that you want. You can specify max item size, the equivalent of that essentially in terms of payload that's going into Kafka. You can specify the max size for a batch if you're doing batch ingestions. And then you can also tune things like how frequently you go to Kafka and poll for changes, right? So they're both tunable, but in slightly different ways. With Cosmos, we're fully managed. So everything is taken care of for you. We get availability SLAs, latency SLAs, automatic failovers, things like that, really about as managed as it can come. With Kafka, you can get a managed offering if you want, going through Confluent. You can also do it self-managed. But really, the managed offering through Confluent is definitely available and very easy for another low hand, no touch setup. So moving into the specifics of the connector itself, here's essentially what we're offering, right? So we've got both source and sink. I think in some scenarios, what you'll see is if you look at the list of officially published connectors for a given data store, you're not always going to see it going on both sides. In our case, we're very clear. We want this to be a dual movement scenario. So there's a lot of use cases for moving data from Cosmos into Kafka. So we have a connector for that. There's a lot of scenarios where you want to move data from Kafka into Cosmos, and we have a connector for that as well. And they're both generally available. And in the case of sync, it's also available fully managed through Confluent. Zero code, we've already covered this in a good amount of detail. The idea is that everything, because it's running change feed under the covers, and it's running a producer on the other side of things, you're literally just saying, here's where I want to connect. This is my Kafka cluster. This is my topic. This is my Cosmos DB account. And this is my container. Kafka Connect, please do the migration in the direction that I've chosen. So that's really all that you need to do. Data formats today, we have JSON and Avro. I think we're still looking at whether, from a use case standpoint, whether there's additional formats that we'd want to support. There's obviously additional things that you get out of Kafka in general, things like protobuf, byte arrays. So there's more. But JSON we obviously need because there's Cosmos DB, which is all JSON. And Avro, it's just makes life easier because it's a single format that every downstream application can pull from, right? And this is fully managed. So we'll walk you through a demo that Alicia is going to walk through in a bit and really just show you how easy it is to just run this through Confluent and just hook the whole thing up end to end.
Yeah, cool.
So in terms of the actual use cases, we see two primary scenarios that Cosmos DB and Kafka sort of come hand in hand. One is on the migration side of things and data modernization side of things. So we've seen a lot of use cases for customers that want to start moving from legacy systems, but also RDBMS systems. And then they want to move into Cosmos for a multitude of reasons, right? I mean, obviously, one is it's a fully managed service, but if you wanted something like 5 nines of availability, you wanted to do multi-region writes, you wanted your low latency SLAs, you want to just be a lot more hands-off and just use Cosmos for all of its power, but not want to be in the business of capacity management and super hardcore monitoring and alerting of your systems on-prem. And so we've seen a lot of these migrations into Cosmos, which obviously comes with a shift in thinking. You're re-architecting your data, re-architecting your applications, and all of that. But Kafka has played a pretty central role in that process. You could, in theory, do things like create a view off of your tables in RDBMS and then take that view and then move that into Cosmos. But now you're burning resources on the source. So the typical scenarios that you will see is something like a CDC from RDBMS systems into Kafka. And then from Kafka, you can do a whole bunch of processing and then move it into Cosmos. And what you have the power to do here by staging things in Kafka is because you can have multiple consumer groups. I could have one Cosmos DB container that's doing one thing. I could have another Cosmos DB container that's taking the same data, massaging it in a slightly different way, and then pulling it into that container for a completely different use case. This also falls into that side of, data duplication in NoSQL is not a bad thing. It's actually encouraged if it's going to help significantly lower your throughput consumption on reads, right?
Yep.
So that's sort of the power here, and that's really where we wanted to be able to plug in and make this very seamless and easy as well. This is obviously a highly simplified diagram, so there's obviously more to it than that, particularly on the second half of this where you're pulling from Kafka and then writing to Cosmos. But even getting it into Kafka, we just wanted to make that as simple as possible. So here what you could do is you could have something like a source connector that's actually pulling from these RDBMS data sources, writing it into Avro, into Kafka. You could have something else that's doing some transformations. You could have something else that's doing even more transformations, maybe writing it into a different Kafka topic. And then from there, you're writing from those Kafka topics into the respective Cosmos DB containers.
So it seems like a well-worn cow path here for this use case is, like you said, it's modernizing your data stores, or maybe it's a migration to the cloud and wanting to use a distributed NoSQL database like Cosmos. Are there built-in transformations? I mean, what I'm seeing is that if you're going from an RDBMS to Cosmos, you're going to want to denormalize your data. Yeah. Are there built-in transformations that allow you to do that? That's simple, or do I have to write code to do that?
So that will require a little bit of code, but it is still doable through the Kafka ecosystem in itself. So what you could actually do is once you have data that has come in, let's say to a single topic or even to multiple topics, there's something called Kafka streams that you can then have on top of that. And there's also something called KSQL DB that you can use along with Kafka streams. So that will give you more of an ability to apply more complex transformations. So something like, let's say you've got 5 different tables, they've all gone into the same topic. And then the next step is you're not just doing single message transformations, you're literally combining data from 5 different topics or 5 different types of data in the same topic, massaging that, converting it into a JSON document, maybe doing something even more fancy, doing something nested within that, and then moving that into Cosmos DB. So you have the ability to do that. That's not something that's going to be through the connector itself. It would come in after the connector has sort of done its thing. And typically what you'll see is even the result of those streams will also possibly go into a Kafka topic if you wanted it to. And then from there, now it's just a one-to-one movement. And that's where the sync connector can come in for Cosmos and then move that data from there as well.
I see. So you would write this, use this KQL, so that you would use that to query the source connector into, say, a DB2 or an Oracle. And then what? And then hydrate that into like a POCO or POJO type class, and then serialize that into a message, and then send it? How does...
It's a little more involved than that. So at that point, you're not quite pulling in from the RDBMS data store. You're actually it's almost like you're streaming on top of your Kafka topics itself. So your data is in Kafka at this point. Mm-hmm. You're streaming that, applying changes, and then the reason you'd want to do it in that layer is because at this point, you're probably doing things like grouping by some particular field, aggregating some particular field, then massaging that and moving it in. So it's essentially streaming on top of your Kafka data. And the Kafka data has now been populated from RDBMS. So the KSQL piece is not looking at the RDBMS anymore.
Got it. Okay. It's in the Kafka store already.
Yes. Yep. Okay. Yep. Exactly.
Cool. I told you I was going to ask them questions.
No, this is actually good. I mean, this is the level of detail that it's not dumb at all. Okay, so this is actually, I'm very proud of this slide. I just
Wow.
wanted to, yeah, it's a template that I found somewhere. Anyways, so this is the second piece in terms of use cases where we're looking at microservice architectures, right? So here what we're trying to say is, at this point, this isn't a data modernization or a data migration type of use case. It could be if you wanted it to be. But here we're looking at just a sample airline set of services. So we're assuming there's probably a service that handles bookings, a service that handles forecasting, and then a service for each of these other components, right? Something that's doing analytics in there, recommendations, and so on. Now, what you might typically see is in a microservice architecture, actually what you will see is each of these guys is doing its own thing, backed by its own data store. So bookings might be on NoSQL, it might be doing Cosmos DB, let's say they're doing Mongo API. Forecasting could also be doing Cosmos DB, and maybe it's doing SQL API. Marketing might be doing its own thing. Analytics is on an analytical store. So they're all doing their own thing to serve their immediate function and built on top of the database that is the best fit for what they're trying to do. But at the same time, they're going to want to talk to one another as well. And equally, they don't know how they will be communicating in the future. So today, forecasting probably needs to pull some data from bookings. Flight recommendations probably needs to pull some data from forecasting and marketing. Revenue optimizer may need to pull from data from a bunch of other things as well. Analytics might pull from literally all of these guys and more. But in order to maintain this communication, if we didn't have something central in all of this like Kafka, what could happen is that you have to build this complex web of relationships between all of them. Bookings has to know about the forecasting data model and the other way around. So if there's any changes that happen in bookings, it has to be carefully coordinated with all these other guys. Same thing is going to happen. In general, if forecasting needs data from someone else. And it also makes it difficult to change. It's not just about changing the data model. It could be about changing the underlying data store altogether. So maybe bookings was on RDBMS and then decided, hey, some of the things that I need to do really are a fantastic fit for NoSQL. I want to move to Cosmos, but how's that change going to impact everybody else, right? So what happens with something central like Kafka is you're now essentially just thinking about your communication with Kafka. And if you make that Avro, it's still a central format, schemas could change. So that's something that will always have to be there. But we don't have to worry about some other guy being built on something else and then having to hook up that relationship to that guy and then finding out whether it's compatible and that web of relationships is just significantly simplified.
Right. Like
Kafka
in the old days, you would just write ETL jobs, or you'd have to go and, the old monolithic apps days, right? Where you have these standalone monolithic apps, and then you've got, I don't know, each have their own different interfaces and languages and libraries for pulling data in and out or something, but it's always a pain to do. This makes a lot of sense in terms of an architecture because you've just got like a centralized bus for data basically.
Exactly.
And you just subscribe to whatever topics you want out of there, right? So
yeah, exactly. And what we're starting to see more so than not is that even for, if we were to assume, like we've got customers that would have a version of this that is fully built on Cosmos DB. So every single one of these microservices is already doing its own thing and it's already on Cosmos DB, but they still want to be able to talk to one another. And this is now going to be significantly simplified because you've just got a central piece with Kafka Connect, pulling from one side, moving it into Cosmos, moving it into Kafka. And then from there, that could be sort of broadcasted out for consumers in any direction. And so it also gives you the flexibility sometimes to do auditing and things like that, where you want to pick up every change in Cosmos and then move it into Kafka. And then you have the ability to replay that over and over and over and over again, as opposed to constantly going to Cosmos, consuming RUs. So there's even some of those use cases where we're not even talking about multiple data stores. It's the same data store in Cosmos, and you have the flexibility to make that communication even simpler now with this architecture.
Yep.
Cool. So now in terms of what's actually happening here, right? So by this point, we've already covered most of this. And We'll look at the source side of things first. So we've got this Kafka Connect cluster running in the middle. And the best way to think about it is it's really just distributed compute. So it's distributed compute that's running an instance of the connector. And it's running the change feed processor under the covers. It's also running consumer and producer code for Kafka, depending on the direction in which we're going. So on the source side, at this point, what we're looking at is moving data from Cosmos into Kafka. So you've got a whole bunch of workers right in the middle in that Kafka Connect cluster. Each one is running an instance for a start, let's say, of the Java v4 client, right? Which under the covers is then spawning an instance of the change feed processor.
Mm.
Now that's running on every single one of these nodes, and then all of these guys know about the topology of your source container. They're talking to each other through the lease collection. They're pushing state in terms of continuation tokens, which worker is looking at which physical partition. And then when they scale out, all of that is already built in. The good thing is because it's running our change feed processor and we've got this way for all these guys to talk to one another, if one of those goes down, we have additional workers that are already there that will just pick up from where the previous guy left off, right?
Does Cosmos or the Java SDK communicate to Kafka such that it knows how many physical partitions we're actually running, just so you're not like stupidly trying to scale out to more than what you could possibly need? Like say there's only 5 physical partitions and you try scaling it out to 10 workers. Is this something that...
Yeah, that's a good question. So essentially what will happen is, and that behavior actually is a great question. That behavior is exactly the same as Cosmos in that you'll have a bunch of workers that are just not going to be doing anything.
Mm-hmm.
So essentially that is handled by the Kafka side of it itself in that you've got these consumers. So in your example, let's say we started off with 5 workers. We expanded that to 10 workers. They're all part of the same consumer group. So they will hit the Kafka cluster and essentially say, I've got these 10 guys that want to listen to changes on 5 partitions. So 5 of them will get assigned. The other 5 will literally just be sitting there doing nothing.
I see.
So that is similar. So yeah, it's actually a great question. So definitely, you do have a little more control on the Kafka side in that you know how many partitions you have because you're literally creating topics with X number of physical partitions for a start. So it's a little easier to do in Kafka. I think on the Cosmos side, essentially what we're saying is if you have a massive number of partitions, have a good number of workers, but don't have something that's overly excessive to
Right.
where it just you're wasting compute. And equally, if you had just one partition, then have at least 2 workers in there so that if one guy dies, the other guy's able to pick up the slack.
Right. Makes sense. Yeah.
Yeah, and essentially on the other end of it, it's so that connector is running the change feed processor on one hand. It's also running the producer on the other hand, which is then pushing that data to Kafka. And this is the exact opposite. So really more of the same thing. At this point, what your workers are now doing for a start is they've got the workers, instead of being thought of as instances of the Cosmos Java client spawning off an instance of the change feed processor. They're now spawning consumers. They're all part of the same consumer group. So exactly to your question, Mark, there's a distribution or an allocation rather of physical partitions to each of the consumers in the consumer group, and then they're just moving that along to Cosmos DB on the other side of it. So this is pretty straightforward. And with that, I will hand it over to Alicia to do a quick walkthrough of a demo through Confluent and really show the connector working.
Awesome. I can't wait. Let's get you up here. Yeah.
Thank you. That was great, Abinav. You went through so much detail there, and I really hadn't realized how similar the technologies were until you broke it down that way. So I'm going to go ahead and try to link the 2 technologies together as we walk through this. Right now, I'm going to go ahead and start on my Confluent Cloud instance. And I've got my Confluent Cloud cluster, and I've also got an instance of Cosmos DB in my Azure portal. Now, going back to what Abinav was saying about similarities, what we're going to do is we're going to create our container not only in the Azure portal on our Cosmos DB instance, but we'll also go ahead and create our container in Kafka within Confluent Cloud. So I'm just going to go ahead, and I do have a database called Connect Demo here, and I'll go ahead and use that existing database and create a container called product. I'll go ahead and use the default partition key of ID, and we'll go ahead and kick that off. Now, what we're going to be doing is we're going to go ahead and create some temporary testing data, and we'll go ahead and send that data to Kafka into a topic, and then we'll go ahead and create a connect instance to send that data to Cosmos DB. And so our container is going to, in Kafka, is going to be called a topic. So we'll go ahead and create a product topic. And I'll go ahead and drop this number of partitions to 1 because this is a demo environment. And now we have containers on both sides to send data to. I haven't been working with Kafka for that long, but it was pretty amazing to start working with their data gen connectors. And what a data gen connector is, and for my AI friends out there who need data to create models, it's very interesting once you extrapolate what we can do, because there's only a finite amount of real data, right? But the data gen source connector is a collection of data generators that is available within the Confluent Cloud environment.
This is like a bogus for Confluent or for Kafka?
Yeah, it's so, how do you test a stream unless you have data? And so anybody who creates a stream needs test data. So they've got a collection of fake data generators, and it's very well documented on GitHub. So you can play around with the different schemas that match your scenarios. But this kind of blew my mind the first time I used it, because, if you're not passing data through your data stream, then how do you know if your data is getting from one end to the other, right?
You just put it into production and wait and see what happens, I guess, is what you do.
Only on Thursday nights, right?
Well, yeah, right. No Fridays. So make sure nobody's there all weekend and it's sitting there flapping like a fish.
Right. So now the data gen does run on your resources. So we're going to go ahead and add in your key and secret here. And this is that container that I had set up. So I'm generating this fake data. So where am I sending this fake data to? I can go ahead and pick from Avro, JSON, or protobuf. We'll go ahead and select Avro. And then these quick starts are going to be these documented fake data schemas that they have available.
Yeah, cool. All right. So I see all the kind of the major ones you would normally see or need in there.
Yeah.
Click streams, orders, inventory, product, ratings, stock trades, users. Yeah, cool. I'm going to play with this.
You're welcome. So mission accomplished. I always hope to expose somebody to one thing they haven't been exposed to before when I speak. So thank you.
There you go. Yeah. Well, look at, hey, I work in a database product, so I need every single demo I write. I need to generate data. So maybe I'll just take some of my demos and then just connect it to this thing.
Yeah, I would be happy to work with you on that, and we can do a little write-up afterwards if you'd like. And there's countless numbers of ways to use it, and but my mind was, you know, oh.
Well, you guys are like us. You need data, right? So that's cool.
So now we have our data running on the Kafka cluster, and it's setting things up in the background. Now, when you work with a managed instance or a managed Connect instance on Confluent Cloud, what happens is you don't handle any of the provisioning or the scaling out or, you know, administratively for bursting. So what we've done is we've uploaded a connector file, and that is being placed onto an abstracted Kafka instance, and all of that provisioning and scaling is being handled for you. So other than entering in my very minimal configs, we're good to go with the DataGen connector. And we can see that we just pointed to our Kafka cluster to point to resources, and there is very minimal configurations here. So I can go into my topic, and we've got our product topic, and we can take a look at messages really quickly. And we can see that we have messages being sent into the topic.
Yeah, and just really quick, this was sort of that, you know, that similarity that we were addressing earlier as well, in that here, instead of continuation tokens, we've got offsets. But in addition to that, we've also got a timestamp associated with that offset, so that sort of makes some of that estimation easier on the Kafka side. Yep.
Now, when you're in Confluent Cloud, you'll have the ability to look at both the self-managed connector and the fully managed connector. So this connector on the left-hand side is going to be the self-managed connector, and this is built, validated, and verified by the Microsoft team. So that was Microsoft Commercial Services working with the Cosmos DB development team, and tons of documentation in GitHub and use cases, and they're actually working very, very quickly on getting updates into that. And what we're working with today is going to be the fully managed connector. So the fully managed connector is going to be the configuration that integrates directly with the Confluent Cloud. So we're working with the sync connector, which means we're pulling data out. So we'll go ahead and pull data out from the product topic. And we're generating data in type Avro out of the DataGen connector. We can also go ahead and pull data in the Avro format. And the Cosmos DB connector will go ahead and take care of that data transformation so that it's inserted in JSON. I'll go ahead and enter in my API details here. And then we've also got our Cosmos DB credentials that we'll be entering in here. Just 1 second while I cut and paste. Now, a little further on, you'll notice that we have a topic container map field. And what the topic container map field is going to let us do is to identify which topic data we'd like to put into which container. So what this actually allows you to do is you can actually run multiple imports at the same time.
Okay.
So I'm just going to do an easy, we had called our topic product, so I'll go product. And we're going to use the Kafka metadata strategy. And this is going to be a strategy for if your data doesn't have that primary key to start with, then the converter will go ahead and add that field in for you and map it up to the container ID on insert.
So that's taking, you're saying that's going to read the source container and figure out what its partition key is, and then translate that, or am I misunderstanding this? Can you explain the ID strategy more to me?
Yeah, actually, Abinav, I think we had, if you could take that one, and I think he was a little more involved. Thank you.
Sure. Yeah. So in this case, it's not for the partition key, Mark. It's strictly for the ID field. So essentially what it's saying is if the ID field doesn't exist, then is there something specific that I want to do to inject a certain format of an ID field? So you can pick a GUID and things like that, or you can just pick one of the fields in your, well, what would be Avro before it gets converted into JSON. Can I just pick one of those because you feel like that would be unique enough to be part of the ID? So it's very similar to what we used to do in the bulk executor back in the day, where we had some way of saying you've got a whole bunch of data coming in. Do you want to let Cosmos pick the ID for you, or do you want to have a way in which you can inject an ID even if the original source of the data didn't have it? So that's sort of what it's doing. The partition key thing isn't there. That's something that we're still thinking about in terms of how do we want to do that if the user also wants to do this for the PK. Mm-hmm. It just so happened that in this case, the ID was also the PK, and so it ended up having the same effect.
I see. Is it sampling some of the messages to help it decide whether it could use one of those properties as an ID?
Not quite. So it's literally just picking one of the fields that are pre-specified, essentially. So it's not doing a sampling either. So this is similar to what happens in an SMT, where it's literally just per document, we're picking a field and then going with that.
I see. Okay.
Thank you. So we'll go ahead and kick that off, and we'll go back to our container. And we're still in provisioning state, so we'll just give it a bit.
Yeah, I'm guessing it takes a minute or two to spin up everything in there. There's nothing quite as exciting as watching stuff get provisioned, is there? My favorite demo. Yes. Uh-oh, no.
Uh-oh.
Oh, I love this. All right, let's see what happens. Let's see if we can figure this out.
So what I will do is I will go to my backup, and I probably fat fingered my
your keys.
My keys.
Yeah.
And sometimes I cut and paste in the spaces, and it doesn't like that. So I do have.
You already have a pre-made cake in the oven?
Yes,
okay.
Absolutely. I get so excited when I talk to everyone about new things, right?
That's all right.
And we'll go over to items and see if it's in there. And there you go.
Hey, some data. Let's take a look. What's the message that it sends over the product?
So this is, fake data.
Yep. So this is data that came out of this data generator that you guys have, right?
Yeah.
Okay.
So if we were to track the flow here, Alicia, essentially what we have is we've got a data generator that is writing a sample product data with those 4 fields in Avro format into your product topic. In addition to that, we spun up a Kafka Connect cluster with the Cosmos DB sync connector, which is essentially pulling from that Kafka topic that we essentially set it up to talk to. It's pulling in that Avro data, making a transformation into JSON, also adding an ID field in this case, and then writing that to the product container in Cosmos. Is that the correct flow?
Yes.
Okay. Yep.
And we can go into topics actually, and we can see some of the messages that are sitting in the product topic going.
Yep.
And it's exciting big data.
Yeah, and we see that offset growing as well. So that data is still coming in. Nice.
I see. So that's what you were talking about earlier, Abinav, is this offset, and you can use it to track kind of the rate at which you're reading off Kafka.
Yeah. So in this case, they've got an offset, but also a timestamp associated with that offset. So essentially, it's very similar to what we do with continuation tokens on the change feed side. So on a particular partition, and it's actually offsets associated with a partition. So there we're seeing that it's partition 0 because in this case, we created a Kafka topic, which is one partition. And so on the consumer that's picking up these changes from that partition, it essentially says, okay, I've gotten changes from offset 1 to 100. Now let me go back and get changes from offset 100 to 200. But if you know that currently we're on offset 1320 something, that's how far behind you are from the latest set of changes that came into your Kafka topic.
Got it. Can you monitor? Are there Alicia or Abinav, are there tools to monitor that offset and then use that to kind of auto scale, or is that kind of just all built in? You can just say put auto scale on this cluster.
I think you can. That's a good question. So you're talking about auto scale on the Kafka Connect side, so that there's more workers to pick up changes faster, right?
Yep.
I think you can do that. The thing, though, is that would be more applicable if you have more partitions, because within the scope of one partition, because there's only one consumer that could pick it up,
Yeah.
Adding more workers wouldn't help in that scenario. But
Right.
But to your point, if they're being slowed down because there's not enough workers and too many partitions, then we can definitely look at that and also scale it out as well.
Right.
I'm not sure if that's automated, but I'm sure there's ways in which that can be done.
Yeah, cool. Well, all right. Is there more to show?
We are good for today.
What's that?
Oh, we're good.
Okay.
I think.
Well, I got some.
I know we've changed your life today. So
You did. That data generator changed my life. So I'm going to play with that. So I wanted to share some links with some of the viewers here. So this is the blog post I think you guys published. It was just this week. Was it Monday, Tuesday? What day did you guys publish?
Yeah, I believe it was on Tuesday. I think it came out on the 10th, if I'm not mistaken.
Okay. Yeah. So just a couple of days ago. So you can read all about the Kafka connector for Cosmos DB that just went GA this week here at that blog post. And then I don't know, you guys are doing, is it, I guess, a web seminar or something coming up here?
So that's also being done in partnership with the Confluent team. So there's a link where anybody that's interested could actually go in and register for the Confluent seminar. And essentially, we're going to be talking about the same thing. They're going to be doing, it's more on the demo side of things in terms of having something from a relational data store hooked up to the Kafka connector and then eventually making its way into Cosmos. So they're looking at it as more of a seminar, but we're working closely with them to talk about some of the salient features of Cosmos DB as well, if you will.
Okay. When's that coming up?
That is on the 30th of August.
Okay. Well, if anybody would like to register and check out this Confluent seminar, you got a link there at the bottom of your screen. You can just take a screen cap of that. And then also, I showed I think it was the sync connector README, but if you'd like to see the README for the source connector, I can share that with folks as well in there. And yeah, I am super excited to see all this today. You guys were great. Lots of fun. Even demos blowing up, which is super awesome as well. I like it shows we're just doing this without a net here on the show. So that's all good. Well, thank you guys, everybody. So some announcements. We've started a new Azure Cosmos DB user group, virtual user group, and we're going to start monthly meetups in September. Wednesday, September 22nd. Oh, here, let me get the URL up here. Wednesday, September 22nd, 2 p.m. Pacific time, which is 10 p.m. London and 7 a.m. Sydney. So come check out our very first Cosmos DB user group hosting me. I'm going to host the very first one. And I'll talk about modeling and partitioning in Cosmos DB. Also, Cosmos DB team is teamed up with the Azure Functions team, as well as the SQL Serverless and the Logic App folks. And we're going to run our very first Azure Serverless conference. Azure Serverless Conf is what we called it. Anyway, CFP is open until tomorrow. It closes. So if you're if you're a dev and you do lots of serverless apps and you want to present, maybe get a session in our conference, you could submit it there. Or if you just want to come and check it out, you can register now. We've got a landing page open, so you can come and register, save the date. And then come watch Azure Serverless Conf. It's going to be the end of September, September 29th and 30th. And I guess also, if you've got any show ideas, just hit us up on Twitter at Azure Cosmos DB. It's mostly me keeping an eye on that. So if you tweet at us, I'll respond to you. Maybe I'll respond. So that's it for the show this week. Next week, join me. It'll just be me next week. We're going to talk about all things kind of ARM and PowerShell and CLI and all the Azure management goodness. I'll talk about our resource provider in Cosmos DB. So it's going to be fun, exciting. We'll laugh, we'll cry because it's ARM templates after all. Right? So anyway, that's it for this week, folks. Abinav, thank you so much for joining us. And Alicia, great to see you again. Thank you very much.
Thank you.
Thank you.
Okay, thank you. Bye-bye. Bye, everybody.
Bye.